Earned value management, EVM, in its various forms is a commonly used method of performance measurement. It integrates project scope, cost, and schedule measures to help the project management team assess and measure project performance and progress. It is a project management technique that requires the formation of an integrated baseline against which performance can be measured for the duration of the project. The principles of EVM can be applied to all projects. In any industry, EVM develops and monitors three key dimensions for each work package and control account. Planned value, PV, in a very straightforward manner is the answer of the question, as of today, what is the estimated value of the work planned to be done? In other words, it is the authorized budget assigned to the work to be accomplished for an activity or work breakdown structure component. It includes the detailed authorized work plus the budget for such authorized work, allocated by phase over the life of the project. The total of the PV is sometimes referred to as the Performance Measurement Baseline, PMB. The total planned value for the project is also known as Budget at Completion, BAC. Earned value, EV, in a very straightforward manner is the answer of the question, as of today, what is the estimated value of the work actually accomplished? In other words, it is the value of work performed expressed in terms of the approved budget assigned to that work, for an activity or work breakdown structure component. It is the authorized work that has been completed, plus the authorized budget for such completed work. The EV being measured must be related to the PV baseline, PMB, and the EV measured cannot be greater than the authorized PV budget for a component. The term EV is often used to describe the percentage completion of a project. A progress measurement criteria should be established for each WBS component to measure work in progress. Project managers monitor EV, both incrementally to determine current status and cumulatively to determine the long-term performance trends. Actual cost, AC, in a very straightforward manner is the answer of the question, as of today, what is the actual cost incurred for the work accomplished? In other words, is the total cost actually incurred and recorded in accomplishing work performed, for an activity or work breakdown structure component. It is the total cost incurred in accomplishing the work that the EV measured. The AC has to correspond in definition to whatever was budgeted for in the PV and measured in the EV, for example, direct hours only, direct costs only, or all costs including indirect costs. The AC will have no upper limit. Whatever is spent to achieve the EV will be measured. The three parameters of planned value, earned value, and actual cost can be monitored and reported on both a period-by-period basis, typically weekly or monthly, and on a cumulative basis. The figure uses S-curves to display EV data for a project that is performing over budget and behind the work plan. Variances from the approved baseline will be monitored. Cost variance, CV, is a measure of cost performance on a project. It is equal to the earned value, EV, minus the actual costs, AC. The cost variance at the end of the project will be the difference between the budget at completion, BAC, and the actual amount spent. The EVM curve is particularly critical because it indicates the relationship of physical performance to the cost spent. Any negative EVM curve is often non-recoverable to the project. Schedule variance, SV, is a measure of schedule performance on a project. It is equal to the earned value, EV, minus the planned value, PV. The EVM schedule variance is a useful metric in that it can indicate a project falling behind its baseline schedule. The EVM schedule variance will ultimately equal 0 when the project is completed because all of the planned values will have been earned. EVM SVs are best used in conjunction with critical path methodology, CPM, scheduling and risk management. The SV and CV values can be converted to efficiency indicators to reflect the cost and schedule performance of any project, for comparison against all other projects or within a portfolio of projects. The variances and indices are useful for determining project status and providing a basis for estimating project cost and schedule outcome. The Cost Performance Index, CPI, is a measure of the value of work completed compared to the actual cost or progress made on the project. It is considered the most critical EVM metric and measures the cost efficiency for the work completed. A CPI value less than 1.0 indicates a cost overrun for work completed. A CPI value greater than 1.0 indicates a cost underrun of performance to date. The CPI is equal to the ratio of the EV to the AC. The Schedule Performance Index, SPI, is a measure of progress achieved compared to progress planned on a project. It is sometimes used in conjunction with the Cost Performance Index, CPI, to forecast the final project completion estimates. An SPI value less than 1.0 indicates less work was completed than was planned. An SPI greater than 1.0 indicates that more work was completed than was planned. Since the SPI measures all project work, the performance on the critical path must also be analyzed to determine whether the project will finish ahead of or behind its planned finish date. The SPI is equal to the ratio of the EV to the PV. Equation: SPI equals EV divided by PV.